Your Toyota is burning more gas than it should, and the fix costs less than a fast food meal. Right now, there is a tiny sensor inside your engine bay that controls how much fuel your Toyota burns on every single drive. When it is clean, your engine breathes perfectly, fuel trims stay tight, and you get every mile per gallon Toyota engineered into that powertrain. When it is dirty, and after 30,000 miles it almost certainly is, your engine control module starts guessing. And when the engine control module guesses, it guesses rich. That means more fuel, less power, and money bleeding out of your exhaust pipe every time you drive. The sensor I am talking about is the mass airflow sensor, and cleaning it is one of the most powerful ways to restore fuel economy on any Toyota. We are talking about a sensor that costs nothing to clean, takes less than 10 minutes, and has been dyno proven to recover lost horsepower and restore the air to fuel ratio your engine was designed to run. Most Toyota owners have never touched theirs. Most do not even know where it is. And that is exactly why so many Camrys, Corollas, RAV4s, Tacomas, and Highlanders are quietly losing 2 to 4 miles per gallon without a single warning light on the dashboard. Let me show you exactly what is happening inside your engine and why this one sensor matters more than almost anything else under the hood. Every Toyota with electronic fuel injection uses a mass airflow sensor to measure the exact volume of air entering the engine. On most Toyota models, this sensor sits between the air filter box and the throttle body, right inside the plastic intake air tube. It is a small housing, usually held in place by 2 screws or a clamp, with an electrical connector plugged into it. Inside that housing is where the magic happens. Toyota uses a hot wire design. There is an incredibly thin platinum wire suspended inside the sensor element. When the engine is running, the engine control module heats that wire to a precise temperature above the incoming air. As air flows over the wire, it cools the wire. The engine control module measures how much electrical current is needed to keep that wire at its set temperature. And from that measurement, it calculates exactly how much air is entering the engine. That air mass reading is the single most important number your engine control module uses to determine fuel injection. Every time a fuel injector opens, the duration of that pulse is calculated primarily from what the mass airflow sensor reports. When that sensor reads accurately, the engine control module delivers exactly the right amount of fuel for perfect combustion. Horsepower stays where Toyota designed it. Fuel economy stays where the window sticker promised. Emissions stay clean. But here is the problem most Toyota owners never think about. That platinum wire sits directly in the path of every cubic foot of air your engine inhales. Even with a clean air filter in place, microscopic particles of dust, pollen, road grime, and oil vapor pass through and gradually coat that wire. Over thousands of miles, a thin film of contamination builds up on the surface. That film acts as insulation. It prevents the incoming air from cooling the wire as efficiently as it should. The result is the sensor underreads the actual airflow. It tells the engine control module that less air is entering the engine than is actually coming through. The engine control module responds by reducing fuel injection to match what it thinks is a smaller volume of air. In some cases, the engine runs lean, which causes hesitation, rough idle, and poor throttle response. In other cases, the oxygen sensors detect the lean condition, and the engine control module compensates by adding fuel back in, but it overshoots. Now the engine is running rich, burning more fuel than necessary, building carbon deposits, and slowly degrading catalytic converter efficiency. Either way, you lose. The worst part is this degradation happens so gradually that most drivers never notice. You do not wake up one morning and suddenly lose 3 miles per gallon. You lose it over months, a tenth of a mile here, a quarter mile there. By the time the tank average looks wrong, the sensor has been lying to the engine control module for thousands of miles. Industry data from the EPA shows that dirty airflow sensors can increase fuel consumption and emissions by up to 10%. On a Toyota averaging 28 miles per gallon, that is nearly 3 miles per gallon lost. If you drive 12,000 miles a year, recovering even 2 miles per gallon saves you roughly 35 to 40 gallons of fuel annually. At current gas prices, that is money disappearing into the atmosphere because of a sensor that takes 10 minutes to clean. Cleaning it does not require a mechanic, a scan tool, or any special skills. The mass airflow sensor cleaner itself costs between $7 and $12 at any auto parts store. That is less than a single gallon of premium fuel in most states. Now let me explain why you cannot just use any cleaner. This is where a lot of Toyota owners make a critical mistake. The platinum hot wire inside the mass airflow sensor is incredibly delicate. It is thinner than a human hair. Using carburetor cleaner, brake cleaner, throttle body cleaner, or compressed air on this sensor can permanently damage it. Brake cleaner leaves chemical residue that bakes onto the wire under heat. Carburetor cleaner is far too aggressive and can dissolve the protective coating on the sensor element. Compressed air can physically snap the wire or bend it out of calibration. The only product that should ever touch this sensor is a cleaner specifically formulated for mass airflow sensors. The original product in this category was designed with a formula that evaporates completely, leaves zero residue, and is safe for the plastics and delicate electronics inside the sensor housing. That specific type of cleaner has been DYNO tested and proven to restore horsepower and improve the air-to-fuel ratio back to factory specifications. Using the wrong product does not just fail to clean the sensor, it destroys it. A replacement mass airflow sensor on a Toyota can run anywhere from $80 for an aftermarket unit to over $250 for a genuine Toyota OEM part, plus labor if you cannot install it yourself. A $7 can of the right cleaner prevents a $300 mistake. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribe to my channel. This helps me bring you more honest car advice. Here's how the cleaning process works on most Toyotas. With the engine off and cooled down, locate the mass airflow sensor between the air filter housing and the throttle body. On most Camry, Corolla, RAV4, and Highlander models, it is a small plastic unit bolted directly into the intake air tube with an electrical connector on top. Unplug the electrical connector first. Then remove the 2 screws or bolts holding the sensor in place. Some Toyota models use Phillips head screws. Others use Torx security bits, usually T20. Gently slide the sensor out of the intake tube. You will see the sensor element inside, a small probe with the hot wire or hot film exposed. Hold the sensor with the element facing downward so that any debris falls away from the sensing element rather than deeper into it. Spray the mass airflow sensor cleaner directly onto the element, using short controlled bursts. 2 to 3 sprays are usually enough. Do not touch the element with your fingers, a rag, a brush, or anything else. Even the oil from your skin can contaminate the reading surface. Let the cleaner evaporate completely. This usually takes 2 to 3 minutes. Once dry, reinstall the sensor in the same orientation it came out. Reconnect the electrical connector and make sure the clip seats firmly. That is it. The entire job is done. But here's what separates the smart Toyota owners from everyone else. The cleaning itself is only half the equation. What matters just as much is what you do after the sensor is reinstalled. When the mass airflow sensor has been reading incorrectly for months, the engine control module has been adapting to those bad readings. Toyota's engine control module uses something called long-term fuel trim, which is a learned correction the computer applies over time to compensate for changes in sensor accuracy, altitude, fuel quality, and engine wear. When you suddenly restore the mass airflow sensor to accurate readings, the engine control module is still running on its old learned corrections. The result can be a brief period of rough idle, slight hesitation, or a feeling that the engine is not quite right. This is normal. The engine control module needs driving time to relearn its fuel trims based on the now accurate airflow data. A calm 15 to 20-minute drive at moderate speeds, mixing city and highway conditions, allows the engine control module to recalibrate. Within 1 to 2 drive cycles, the fuel trims stabilize, the idle smooths out, and the engine settles into the efficiency Toyota originally programmed. Some Toyota owners go one step further and disconnect the battery for about 10 minutes after cleaning the sensor. This forces a full engine control module reset, clearing all stored fuel trim data and allowing the computer to start fresh. On most Toyotas, this reset also clears the adaptive idle speed, the learned throttle position values, and any temporary correction tables. The advantage is a faster relearn. The disadvantage is that your radio presets, clock, and automatic window memory will also reset. Whether you do a full reset or let the engine control module adapt naturally is a matter of preference, but either way, the result is the same. The engine returns to factory-level efficiency within a few drives. Now here's why this matters more on some Toyota engines than others. Toyota's 2ARFE 4-cylinder engine, found in the Camry and RAV4, is particularly sensitive to mass airflow contamination because of its variable valve timing system. The variable valve timing system, called VVTI, adjusts cam timing based on engine load, which is directly calculated from the mass airflow reading. When that reading is off, the VVTI timing does not optimize correctly, and the engine loses both power and efficiency simultaneously. The 2GRFE V6, used in the Highlander, Avalon, and Lexus ES350, shares the same sensitivity because it runs dual VVTY on both intake and exhaust cams. A contaminated sensor on that engine throws off timing optimization across 6 cylinders instead of 4, and the efficiency loss compounds quickly. Even the bulletproof 1GRFE V6 in the Tacoma and 4Runner responds noticeably to a clean mass airflow sensor, especially at altitude where air density changes already challenge the fuel metering system. There's one more factor most people overlook. The mass airflow sensor does not work in isolation. It shares the intake air tract with the air filter and the throttle body. If the air filter is dirty or poorly sealed, contaminants bypass the filter and accelerate sensor fouling. If the throttle body has carbon buildup restricting airflow, the mass airflow sensor reads lower volume even when it is perfectly clean. The smartest approach is to clean the mass airflow sensor every time you change the engine air filter, which Toyota recommends every 15,000 to 30,000 miles depending on driving conditions. That way, the sensor always works with fresh filtration, and any contamination gets removed before it has time to bake onto the platinum wire under engine heat. Drivers in dusty environments, high pollen areas, or heavy traffic should consider cleaning the sensor more frequently, roughly every 15,000 miles or once a year. And if cleaning does not solve the problem, that is important diagnostic information too. A mass airflow sensor that still causes rough idle, hesitation, or poor fuel economy after a proper cleaning is likely failing electrically. The hot wire may be physically damaged, the internal circuitry may be degrading, or the connector pins may be corroded. At that point, replacement is the correct path. But cleaning first eliminates the most common cause and saves you from replacing a sensor that only needed 5 minutes of maintenance. The bottom line is this: your Toyota was engineered to deliver a specific level of fuel efficiency. That number on the window sticker was not a fantasy. It was calculated under conditions where every sensor reads accurately, every system operates within specification, and the engine control module has clean data to work with. A contaminated mass airflow sensor quietly undermines all of that. It turns precise fuel metering into educated guessing. It makes your VVTi system operate on bad information. It forces the oxygen sensors and catalytic converter to work harder, compensating for errors that started upstream. And all of it adds up to lost miles per gallon, lost power, and unnecessary wear on components that were designed to last hundreds of thousands of miles. A $10 can of cleaner and 10 minutes of your time restores the one sensor that controls more of your engine's behavior than almost any other component under the hood. That is not a hack. That is, Maintenance Toyota should have printed in bold on the first page of every owner's manual. If you are enjoying this video, consider watching the next one where I am sharing more secrets to keep your Toyota running past 300,000 miles.